How will you hear me? All right. So open to Solidity documentation. The Solidity documentation is what are following, and we are going to be using Solidity by example. The we'll be checking contracts on Solidity by example. We're going to bit by bit and explain to us. And first, I want us to understand the theoretical background to Solidity and smart contract, right? So, yes, Solidity is an object-oriented, high-level language for implementing smart contracts. And smart contracts are programmed. Link and just search for Solidity documentation on Google. You see, it's less interesting that comes up. That was dark mode. Okay. I'm coming. Okay. This dark mode is can you see better? Let's come up. Let's go on to that. Okay. Thank you, better. All right. So this is an object-oriented high-level language for implementing smart contracts. Smart contracts are programs that govern the behavior of accounts within the Ethereum state, right? So, and also Solidity is a calling-based language designed to target the EVM, Ethereum virtual machine, influenced by C++, Python, and JavaScript. So, there are different types of programming language, and they are typed by different reasons. And one of it is calling based, so that's where Solidity comes in. So Solidity comes in, and I want us to uh, I want to go to Wikipedia page so that we can go to bit by bit, so that we understand when you say something about Ethereum state, you know what Ethereum state is, object-oriented programming is. So first thing is, so it's a programming language. You all know what programming language are, right? Yeah. It's not to get responses that we for you. So we all know what programming languages are. And so for implementing smart contracts, so what we need to do is what are smart contracts? Smart contract is a computer program or a transaction protocol that is intended to automatically execute, control, or document events and action to the terms of a contract or an agreement. So the objective of the smart contract are reduction of need for trusted intermediators, arbitration costs, and fraud losses, as well as the reduction of malicious and accidental exception. Smart contract commonly associated with cryptocurrency. So basically, what smart contract is a way to find a binding, a form of program, a program that binds agreements, that makes an agreement work between two individuals. How like it? So basically, smart contract, the contract that is smart. You all know what a contract is. When you want to buy a land, you have a contract. Now, imagine a program that works automatically, so that the contract is binding, so that the contract is legal. Like there is no human intermediary between it. There is nobody that is fraudulent in between because it's a computer program. So yes, so that's Solidity is the language that is used to implement this smart contract to execute this execute this contract, right? So it's licensed under GNU and was designed by Gavin Wood and Saki Dati. They are all members of the Ethereum contributors, right? I think that. So this is a statistically type programming language. So what that means is that a statistically type programming language, like I explained the other time, like in programming language, we have two types of language. We have dynamically type and we have statistically type. I would say that Java is a dynamic type language, Python is a dynamically type language. And so that means that when you are writing your code in Python and JavaScript, you don't need to necessarily tell Python that number nine is an integer. From the language compiler by itself knows that nine is an integer. But in a statistically typed language like Rust, like C++, like Solidity, you can, like Cairo, like I said, you have to tell the computer that okay, I'm passing this integer and I'm making it an integer. So it creates the data. There's always the data type of every variable that comes into it. Some language are strongly typed language, and some are loosely typed language. That means that even the loosely typed language, the compiler will see if you figure out some of the types. You don't need to necessarily tell it what the type are every time. But for a strongly typed language, you have to always implement the type. You have to always train. Then that's why you see TypeScript. You can make it use your type, your TS complete. You are writing the right TypeScript. You can tell it to be loosely typed. You can tell it to be strongly typed. You will see the error that your code is not compiling because you didn't define the type well. When you install a package and you don't define the type of that package you install, it will tell you to define the type of that package. So that's why you have to use that's the difference between statistic type and dynamic type language. So and why do you have so yeah, it says static type checking is the process of verifying the type safety of the program based on analysis of the program test, the source code. Now I want us to read something here. It says checking, static type checking for Turing complete language inherently conservative. That is, if a type system is both sound, meaning that it rejects all incorrect programs and decidable, meaning that it's possible to write an algorithm that determines whether a program is well typed, then it must be incomplete. So that means that the statically typed language checks checks if your program the types are correct, and there is like the Turing complete workload. It's just to show you that there is an algorithm that makes sure that what you have typed, the data type you are using is correct at every time. So let's go back to Solidity that brought us here. So Solidity uses ECMAScript like syntax. Do you all know what ECMAScript is? If you don't know what ECMAScript is, ECMAScript, you know JavaScript, you know TypeScript, they are pure state, there's copy state. They are all under the ECMAScript. The ECMAScript is like ECMAScript is a standard for scripting language, including JavaScript, JScript, ActionScript. But JavaScript is the popular thing among the ECMAScript. Like JavaScript is using the definition they've given for ECMAScript. Basically, there's a spec JavaScript used for ECMAScript. It's from this spec they bring that new features, they add new features from where TypeScript is generated from. So ECMAScript. So they say Solidity uses ECMAScript like syntax, which makes it familiar for existing web developers. Okay, and so unlike other ECMAScripts, it has static timing and variable return types. What does that mean? I also don't know that. Okay. Okay. So your return types can contain different arguments. So that was what variable return types mean. So your function has like can return an argument. I think Golang has something like that. And so it has arity. Arity means the number of arguments a function can contain. Language like LLVM also has something like that. Right. So yeah, I think that's that for now. Let's go back to the documentation so that we don't yeah. So it says here that Solidity statistically typed supports inheritance, libraries, and complex user-defined types. And need us to also search for object-oriented programming. So we know what because one of the core thing about Solidity that you need to understand, apart from it being ECMAScript like language, that is object-oriented programming. I will follow you. Please, if you are lost and you don't understand, please don't mind to tell me that. Just raise up your hand. As I'm talking, I'm trying to see where God is lost for somewhere. So, object-oriented programming is a programming based on the concept of objects. So, basically, object-oriented programming is as its word. Your program type when you are writing the program, your code, it's defined by an object. It sees everything as an object. And what are objects? Objects The object is an entity that has state, behavior, and identity. And objects can model some part of reality. So an object is like this pen, right? This pen has a color, it has a shape, so it has a state, the shape it is in, and what it used to do is right? And it has an identity. It has what you see it as a pen. It has a name, it has a color, that kind of thing. So that's what object-oriented programming is. So it sees every data. Every data has its identity. It has its shape. It has a state, and it has like what's the word? Is it has its what's it called? Its behavior. So objects can contain data called fields, attributes, or property, and have action called procedure or methods. Method is what we need to know here. Methods are functions, something like functions. Yeah. So you can go through this to understand um, objects, object-oriented programming. And we have other, we have imperative type programming, so you can search for that. So let's just go back to Solidity. Let's get started. So let's introduction to smart contracts. So let's open remix and open like I say, let's go to the what's the word? Let's go to the documentation so we can follow through. Remix. Before everything I explain now, do you have an understanding of it? Even though you might not completely get it, but you have an idea. Yeah. It's a way of following. Uh, so open remix and so you see remix here. You have your contract, you have your script for deploying your like we did like during the week for deploying it. So you have it here, and we have a test folder to define your test for to test your code. Right? You can write tests on Solidity. Solidity is a very complete language, so it has everything to a programming language. Then you have quick here for formatting. Yeah. So now contract here, create a new file. So go here to your contract. Go to contract, create a new file. Create a new file. You can call it anything. Anything does not exactly. Okay. So let's copy and paste. Let's copy this first program. Okay. Right? Put this space. Space. So we have this. So first thing is that in your Solidity code, you have like the license identifier to define the type of license your code has, right? So that's what it is. A lot of the time, this is default. And then I think so it's got a different license. Most people use like MIT. What the huh? 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 If license. because the Web3 space love to like the Web3 space tries to make is built on open source. It's built on like open source and open access to your code. So a lot of time, and so what the license does is like an open source. There are different license types to define how open source your program is, or the user can do on your code. And that's a significant change to the code base, right? So that's what like this SPDX license and it defines like the type of license your code has. Then this first line is to define to tell the Solidity has been known in an oriented programming language, the statically type programming language. It's also a compiled language. So that means that it has a compiler that compiles this code. Right? Or remix has compiler. A lot of times you just come here and you just compile. But like you are meant to literally on your laptop, you are meant to like set up like a compiler, it's an SOLC, Solidity compiler to compile your code. If you are only like shows like Solidity, because a lot of time we have adapts that help us to do that. So you see when you do MPX adapts compile, it does that without us knowing what is going on underground there. So this pragma Solidity it tells the compiler the kind of version it's using. So every version comes like some versions have changes. Like different versions have like the API that's like the function you can use and the one that is not available. So this tells the compiler the version you have. So it identifies the nature of your code. So okay, so this is a simple storage contract. However, so only anyhow that from what we've done through the can anybody just stand up and explain what is here so that from what we've learned over time, from what personally yes. So this is initializing okay. And variable taking a type of an unsigned entity. Okay. An unsigned entity that means it doesn't allow everything. So now we are initializing an unsigned integer variable named stored data. Okay. And after that, we are creating a function. Everything inside the function. So I can't get that. We have a contract. We are creating smart contract. This contract covers everything. Okay. Then now we have a function inside. This function, we are setting a parameter of x. Okay. Now we are the parameter that we set it, we are giving it back. For those that still begin, what the 90 parameters are? Okay, when we are creating this function, the function takes in the parameter, and then when we want to use the function later on, the parameters are saved as arguments. Okay. Do you understand that? So now we are also creating a get function, which gets the stored data here. Argument. Argument. Let's say I want to create a function that does addition of a plus b. So I say function add a over b. Those are the parameters. But when I want to use the function I'm going to function and I replace the a plus b with 8,4. So that's 8,4 are argument. Okay. All right. Like I said, first thing you must understand that Solidity is an object-oriented programming. So everything is an object, right? So what we did here is that this first thing, this contract, like I said, in a oriented program, like this contract is more of like a class. Do we get? So this is like a class. It's like defining a class. It's like defining a class. So that's what the contract is. Now we create an object, and that object is of a data type of an unsigned integer. Like you said, the simple explanation is that we don't unsigned integer is that it has a limit of it's only as a positive variable as a limit. Right? Signed integers, like if you use something like int instead of unsigned one, you can afford to use like negative values as the object. So we create an object called stored data, and that object has data type, like say the statistic type programming language. Right now, in the Wikipedia, this thing we say that object programming language programming is a programming paradigm based on concept of objects. I would say an object is an entity that has state, behavior, and identity, right? And we say that objects can contain these objects can contain data and have actions that can perform called procedures or methods implemented in code. So this let's actually this so these are our objects here. It can contain data, stored data of data type unsigned integer. Do we get that? This unsigned really don't tell now that unsigned integer like that's in Rust because Rust defines the what is it? Okay, sorry. So on this unsigned integer, right? In Rust and some other programming language, they define the length in the because Rust is a programming language, so it goes to the far left to define if it's a 8 byte type of integer or 16 or 32 or 20, right? But for Solidity, we are not really dealing with a lot of things, so we just define the type. Like that's another type of defining types for like the Rust that you have or C++ that you have that in C++. And so you see that we check now. This is a 256. You just use the max. Yeah, I don't know if there's the probably might be a method. Yes, it might probably be a method of defining that. For an average, like default unsigned integer is 256. Yeah, right. So like I said, so we create this object. It has a data. Okay. Everything is a variable, function, everything is an object. Object-oriented programming, everything is an object. See in JavaScript, all of these languages like that. See everything as an object first, so you know how to like deal with them, right? So like you said, what an object can contain data. Sometimes it does not contain data. An object can contain a dictionary, can contain a list, right? This is like yeah. So this is the data. This object, the data in the object is this stored data, but we've not put anything in that data. But the only thing we've done is that we've created the data types. Like I said, the way you see like the virtual machine, the way you see like an empty box that you create a space. The way we created an object, a space for this stored data. Do we get that? So I will create like a data type to define how it behaves, right? So this stored data, this object stored data, doesn't behave more than an integer, and specifically on unsigned integer. Do you get that? So like we now said, a object can have methods. So this is a method. Like this is a method, right? Now, when you say that object now, this like I use example of this pen, right? This pen has certain feature, it has certain states. So we want to set a new state for this our new object that we have, this stored data object that is a data aspect. So we want to set a new state that this stored data should be X. Do you get? And this X is our parameter that we have passed to it. What the parameter does is that the parameter changes the state of an object of the defined function using the method we are using. So we are using this set method, this set function, to use this x to what? To define our the value for our stored data, right? So that will say stored data is equal to x, right? So now we want to get this public now. It tells us the visibility of our smart contract, of this function, of this method. If we make it private, no other programming, if you write as many functions as possible. Like for example, if you go to this owner contract, it will not have access to our set function if we make it private, but it's public. If we write, you can make it have access to, or any other contract you write, have access to that set function. You get. That's why I'm making this public. Not payable. It's like defining the contract, right? It's defining the contract. Over time, you understand that. But let's just focus on like this. The public being the visibility of it, right? So now we now set this stored data to be this parameter that we set here, right? We also unsigned integer. Now we create a function because it's an object. An object needs to have a set and data to set the properties of the object and also to get the properties of the object you need, right? So we get this we get the data for it. We define the public. What is the thing goes to be? Yeah, read and write. So basically, so your return type, so that's like a view. Now remember they said that Solidity is a very deep programming language. That's a very deep return rather. So the periodic return means that you can redefine the return type. So you are saying that for every object is returning, this is the data type it must return. It's not going to return the string. If you define it to have a return a string, right? But for this program, we are defining it to have an assigned data. So now we are returning this stored data that we have initially. Do we get that? Yeah. Huh? Okay. After basic type means that it has a defined return type. You know in JavaScript now, JavaScript is not a related type. So you can modify your function and you can maybe you pass in an integer or let's say a React component and you get another component from another type. But in Solidity here, once we define the type of what we are returning, it's not going to if you return anything outside of that type, maybe they give you an error. You get. So in JavaScript, I can write a function and I'm passing an integer to it, and I want it to return a string. It will return my string for me. So that's what I told you to return. If you tell this one to return a string now, it's going to give you an error because you defined the return type. Do we get that? Yes, sir. Okay. I mean that you use that. Okay. Anything you are must be of that one. So when I want to make it part of the so does that mean that even though the state must return I cannot return it? No, I'm saying that once you define it to be doing, you can't respond to string. That's what you mean by variable types.
You know that function say you are using UIs, right? The UIs are using so you're not writing for the task that UIs. So now when you are returning now, you are returning that UIs, you are returning that for the task, returning that as your set. So now you are writing to the blockchain for that set, and that public UIs because you are getting what you write.
So one thing you also all know is that, like I said, after that, Solidity is a static type language, object-oriented programming language. It is also a compound language. And now, a compiler does not assume anything. A compiler does exactly what it tells you to do, and it just tells you if what you've done can be accepted in the compiler or not, right? So that's why these types, these integers and everything, is to help the compiler to make our program, is to make our program work, and the compiler not to like. The compiler is like a corrector, it's like a teacher correcting you, right? So we are writing our code so that it doesn't give as much error as possible. So that's why I'm defining all of this. If another person writes this, maybe an experience write this, there are more things they are probably to help the compiler pass the code. You get so that is the view. So like you said, we are returning this stored data. Now, anybody, we are getting it so that another person can have access to this function, to this contract we created. So anybody that is interacting with this contract, they are whatever they are getting. If you use API, you will not get request. So this is basically like a get request for your class, for your contract, right? So we are saying that when you are getting this thing, you don't have access to change the behavior of our object. You get, you're just getting a list of, you're just reading the stored data, or just reading what is inside the stored data.
Not like read only.
Yes, read only. That's why it's view. Yes, view, right? So there are other different is it partial for the argument? This view returns this particular yes, actually there are a number of like yeah, so that's so this like for this program. So let's move forward. There are anybody has any question concerning this now for this example one. If you are watching online, if you have any questions, you can just drop a comment.
Can you just that line can you
Which line?
the divider? This
Okay.
just those brand
You might have these guys.
That's it. That function says because you are writing to the doc, now when you are writing, so that's that's before that. You can see that when you are writing, the gas fee takes more than when you are getting. That one is 20,049. Now when you are getting from the doc impact, you are using just power.
Okay, so
now
so let me so like you what I get from this now. You mix an ID, tells you if you use BS code, you probably will not get it. Because of your using remix, it's an ID for Solidity, right? So it's like you said, it's estimating how much cost. It's like helper telling you, okay, for you to run this program on the blockchain, for this function to work, this is the estimated gas we are going to use. It might be more, it might be less. You get it? So it is assuming like okay, from like the way how this program works, this is the estimated execution cost for this guy. And for this one, this is the estimated execution cost, right? For you, one of the reasons I'm thinking this one has more gas, but this one are right into the blockchain. You get with this set function. Now for this one, you're just reading it, so it doesn't cost more computing for reading. You get so that's why you have this logarithm. If this probably this if this this what's the word this set function gets gets more yeah, so when as it gets more complex, as it does more as it does more intensive computing, the gas fee increases. So for an array now, you are dealing with more data types, more thing. I'm guessing so maybe let's try to change the value. Let's try to do something with this. So let's say I need to work qualify equals to 2x. I'm using my number from x plus x. So infinite gas because we designed the state now. So it just assume if you set this to be an array now, or like let's say we want to convert this to an array, or like we start using arrays, or start using like other data types. We define our own user-defined data types and tell you that use this data type. The cost increases. This might not be exact. You will not use a unit gas, right? It's just estimating. Now it can't really tell you what exactly is going to happen here. So that's that.
I think it's also like most times when you use private and public, like there are times that you need that is
Let me see. Okay.
like that private public.
Yeah, that's it. Yeah, so we want to change to private, that's an infinite gas. And if you notice, our get function to also increase. That's when I get function increase. It was 2,423, it was not 2,400. Reduce it, that's what I'm trying to say. Okay. So, from what I know, the ID has like its own. This particular ID is like an helper. I don't know how it works personally, right? But I know that this is just like this is not the exact gas we are going to use. I don't think the exact gas we are going to use. This is just an estimate gas we are going to use, right? It's just like yes, like time complexity in algorithm. Like you can assume like this is time complexity for this algorithm. Might not be the exact. You get so you have something like that to calculate the gas fee for every function you have. You get does he answer everything? Before move on, any other person? Gas fee. Okay, you don't know what gas fees are. Okay.
I will drop
Let's also that let's just be simple.
can we like can we mess around with that code and like try to do other things? Basically, what we've just done now is that we store the data, like we put blockchain and like we found that same thing. Can we like maybe see store a string or something like that? Just like
Store a
around
string.
with it.
Okay. Okay, it's okay. You want to do personally?
Oh no, I'm just like maybe what we could just mess around a little bit. Like what we just did now, we use this same code.
Okay, let's so that everyone can learn together. So that we try come up and just come and just you've been learning for a while, so you've been learning now. So this storage, this simple storage we have here. Can you just like maybe change the data type, work with it, do something with the set function. Can you do something like that? It's just to solidify the
You can
this everybody can
do like additional
so and then after that,
check for you also check for maybe if the storage data value is higher than it.
so don't Yes, don't worry. We are confused. There's on which one, the function or the data type. But just just make a change to this. Just tell me what I can change. I'll tell you. Okay. Huh? Anything, just play with one. Not play with one. The name of it. Okay. Okay. My storage. Okay. So you know that you can always leave your storage there or contract anything. They want to make it, want to pass a string data. Have you started seeing that the ID is giving us error? Yes. So when you pass, like you see that this X has to be a string, you can't make an integer equal to string. Because that's the JavaScript because it's dynamic type. Huh? So you store the time. So
Those things.
so parameter should be a string cost should be
Change the
what's that? Which one?
like quotation mark is how you define those things.
Okay.
Okay, no, you don't need it. You just define it. You change it.
Yes, why the error was that you have to pass to the memory, you have to pass it through the memory. That was what the idea was. So let me so that you see what I'm doing. And
So how did you know that it was supposed to write that?
so what you see there's an error here. If the ID, because an ID, that collection was the memory of all data for parameters and functions, but none was given. You get okay. So for a string, you have to be once you set the data type to be a string in your parameter, you have to set to the memory of all data so that you can reuse it. So that you can remember that thing. That's why I say you have to set to memory. You get the program can remember the string so that you can read it. So a string has a lot of functions and integer. Like you have like you have functions to work with string like to look out in the number. Yeah, string. So maybe you can explain better.
Yeah, so when you're storing, when you're sample storing, you're storing in memory.
What about all the time?
So all the time, just okay. Memory is just like when you start with that function to the blockchain. So it's not permanent, temporary. But call it that.
I think all the time they go back. Right? Okay, so basically, how's it going? Huh? String. One is memory and all the time.
Yeah, so you call it as more faster than
Memory, yes. And the memory is the temporary.
so we also have storage. We also have storage. So that's why it's not permanent. When you're storing like what is that when you're writing the blockchain. So it's just like when you're writing compared to one constant.
So the error is there. So now every time you see an error, you read the error. So you see there's a different type of error. What's the type of error is shown here? Type error. So this error is specific to the type you set. The string types we use. Yeah. So the data location was either in memory or all data, parameters and functions, but none was given. So we have to our string must have like where this data is allocated to. We are going to use a memory. We are going to set it to memory, right?
That memory of code, so there's another code. I guess from programming, I guess the idea is that if it's like the temporal, just I want to call function to get code on cost time. That means the variable place.
Yeah.
Not in memory.
Yeah.
It's more like a garbage collector.
Yeah, garbage collector. This is from garbage collection. So, like this memory is to set that thing in the memory of your program. Because your program is running in the virtual machine. Okay, there. So once you call the function, it's set to the memory, right? So you can always like reuse it. Yeah, I guess. So, another error is bringing here is return type string. Okay. So you have to return type. So you want us to know what to do. Yeah. Our auditor is working now. So you want to do anything new? Huh? We want to call X equals to like 15, right?
Maybe you can contact community plus another thing. No, let's join another thing.
Huh?
You have to no,
Listen now. Your screen. Yes, it is.
Can we have like an arrow inside the store?
Huh?
Can we have an arrow inside the store?
No.
Yeah. So, like, I think now, first thing is that while we are trying to make references from other programming languages, first thing, remember that Solidity is written for smart contracts. Like, while it is writing like in a programming language, it is specific, that is a specific purpose. So, while you are still trying to bring your development knowledge, Java knowledge, Sharp knowledge, Java knowledge, remember that Solidity is an entire language different from the other programming language they are used to. So you have to understand the concepts of it. So not other programming languages have that. Right? You don't have to worry about that. You don't have to worry about that. Right? So that's it. So let's see if the program is going to compile first. Compile. So you compile. Right?
I'm still getting actually.
What's the
See, unused function parameter.
unused?
I think it's the X that was not. I think it's the X that was not. But I'm trying to change X. Okay. That's the thing I'm trying to get now. Yeah. How do you actually store a string?
I think
No, this person now. Oh yeah, person now. Don't when you have them, just like an list. Okay? So when you press, okay, just press.
that's great.
That's good for that.
Huh?
Now, press. So, why is like that? So you step like this, just like an if. So you can now rise from that. So you can use
Okay. So I don't have to set the string here.
you don't have to say.
I just have to
Unless when you get on yeah. So you can
So
have
this is the part where user interaction comes in.
that.
when I
So
So you are not interacting with it from something like that. Because you are going to
so
right? You are not getting what you know that
that's what I was like, maybe to have like X plus maybe three or something.
okay.
Yeah, or something different.
Okay.
When maybe some maybe unified,
Huh? We don't do it the level. Huh? Okay. Issues of this compatibility.
The string memory inside the function. Yes, string memory. String memory name is equals to my name is. Then you have to store it as.
Okay, yeah.
Yes. And string memory should not be inside the list. You have inside the function. You understand?
Huh?
That string memory should be inside the function. You have the string memory. String memory name is equals to my name is. Then you have to store it
Okay.
data because.
Okay, to remind you of the name. Thank you. Okay.
Remove that one inside the set.
Huh?
Remove that string inside the set. Can you remove it? Let's see. Then on comment store the
You have to declare what this name is. What is now name? Am I using? Okay, I just okay now. Okay, so okay, don't worry. Don't worry. I figured it out. So now, what is it? Now the issue is not this. The issue is uh, okay.
You know, go back. Delete that plus again. No, like, give the space. Yeah. Close. Close it. No, like, go back. Give the space. Yeah, I think it's just something.
Oh no, it's not this. Come here. Does it sorry? So does it collect string data like if I use this? Does it? Seriously, that is comma. Okay. There's even an error. Okay, so you can check. Yeah.
your analysis of data. I think you cannot have the string memory inside the parameter.
Yes, yes. So just remove plus name. Remove plus name. Then store data equals to name plus creating.
Okay. Nope.
Let's
Now,
take
the issue is this.
you probably need to still go through the syntax of this thing, but like this is through the syntax thing now. And we're applying what we know from JavaScript. I think it doesn't this yeah. It's not like I think like this. I think there's another method of use that one is
I need to charge it to you. I saw it myself.
so the one sitting here now, we have to use like
No. So we can now do something like name now. Uh,
So long.
we are saying name because
Give us.
my my name is because
Doing that. That doesn't hold on. Let's try to understand. That the name. What are you trying to understand?
maybe like my name is whatever name you set in so when we set our set here, when you set this name should be our name. So this word name should now be this name, this name that returns should give you my name is okay. So let me create a new.
Why do we have an underscore?
If you can get the variable, I think we will you will string. My name is so I want to when I do pass name our call function, I want it to have like greeting and name together. Together. So this one is every time will be story to memory. So it didn't work. Now this one now will let you put in binary open door and apply type thing. So storage no the issue is not that. The issue is that this plus is working as a mathematical operation, not as a concatenate. So okay, so we leave the wrong way. I do want to.
This is still the same thing.
No, I'm reading. I'm learning. Like, so when if I have to give me the answer, now I read to like put my answer. It's not the same.
We never have to calculate it.
One.
Why is it such a rare one?
I'm not doing it. I'm not working with string. Like string guitar.
So, but if you were if it has done that, because you have added stuff.
Yes, you have to add.
Can we do that first?
Add
Since
it
it's more, suppose more.
for example, me. What you say? Mama, go back. Don't contact me. Yes, string dot concatenate.
Yeah.
Let's try to do that. Okay. We want to use kitchen function. I just call it the kitchen function. Kitchen function. Dot concatenate greeting name. Does it work? Yes, it works. Now get get function as an error. I think it will work now. Yes, it does. So let's compile and set dot yeah, it should work. It should work.
Close.
This one? Okay. Okay.
This is actually the learning process for me. Sorry. So what have you done?
Huh? Okay. Okay. Yes. Uh, so let me explain this now. Are we all here? If you are some of us have been doing now, we are here and you are not really following. Okay. So what we have to do here, we created a string name, right? We created a string name. Now we have another. We created another new string, another new string object of underscore name. Basically, what a lot of time we use underscore is just whenever we want to manipulate or when we want to change the state of a declared variable, this variable here, and we don't want the compiler to instead we can use something like new name instead of underscore, right? But because we still want to like so instead of using something like new name, so we use something like underscore name just to still tell our is for it to be readable to us. That is still the same name that is reference, yes, reference that is still the same name for us user, but to the compiler, it's a different variable. Do you get? So for every variable we have, for every string, make sure we always remember to put like memory to pass to memory. Right? This thing is like I'm very
Right. For certain data types, you have to change.
But when you're working,
it's just as built-in types. So you can't do more than 0, 1, 2, 3, 9. So I can define. Yeah. So now in Solidity as a language, so why some languages support using addition as like to concatenate words. Also like Solidity has like a built-in type to this built-in function rather to this type of thing called concat. Do we get it? So what we did is that we created another new variable to tell the compiler that we want to pass a greeting that my name is. We can make it another. We can make it hello world or hello something. Then we want to now concatenate, meaning concatenation means adding join two words together. We want to join this string greeting and this name together to give us this our fast you get uh, we return name in the getters. This setters function modifies the object name, right? And this getter returns this name, right? I don't know if this works. We can let's see if we want to return another does declare variables have options. And I'm seeing if you can return after there's no that in the game. You have to set it to okay. So like this is just like return name and you get we have our name. We can return more than one thing. Right? Yes, we can return more than one thing. So if we have like other stuff here that we've done, right? Maybe we want to, maybe a concept to no to uppercase like this. Right? So we want to say that string upper name upper name is equal to okay, pass to memory. Memory. So, what
Put underscore. Put underscore. Because they are very easy.
no, you don't have to
Like, yes.
the upper name was
Yes.
this is that to.
There should be.
It's now when I mean this underscore is for us. Right? So it's just like we can as much as I use underscore, we can say new name, right? So it doesn't have it's not compulsory for you to use like that. You see when we use the name, so you say this declaration charges an existing declaration that already declared. So that's why we have to call it a new name. So underscore. So for us, we know that it's the name of a person, right? So uh, remember to overclick not form the non visible after argument if you invite the pointer. So you have to do pointer. Okay. Training on with something like this. Maybe work. Okay. So uppercase. Maybe work. Okay. Coming. Let's start for that soon. Okay. Okay. So apparently, so this doesn't have it doesn't have what's the word a built-in function for converting to uppercase. So you have to write a function to convert to uppercase. So because of time, we don't do that. So I just wanted to show that we can pass we can return different things in our data, right? Yeah. So let's return. Yeah. So let's continue. So you have to use the reference. And then you have to be double someone. Whenever you yes, don't use a single one. Yeah.
Okay. So that's okay. So now we just said I'm going to complete blockchain. So the next one is just like the first line says that software is like so that the different version 3.0. So for that license, just like what contract itself, sorry, the collection of code stuff like that. Okay. So this another contract like there's comment.
I think I have to go. Can you check what the problem is? trying to, like, I've already compiled and deployed, but I'm getting, not like an error, I'm not getting the data I'm supposed to get. So, I don't know. Yes, I have. There is one other.
So these are the example of contract under contract. So this contract is just like coin contract. So first of all, they already talked about the identifier. So this one is given GPL. The license is GPL 3.0. So this one you can anyhow you can change it to MIT. So you can do that. Yes, yes. So what's the meaning? Eh? Come again. Fragment. Fragment is just like saying that the kind of validation of service you want to use. You can say that we are using from 0.8 to the latest one. So yeah,
So, uh, compiling and deploying is basically a module of saving your stuff.
so I just did research on all the types of quality we have, like the MIT, the CL. I think that's the one that I know. Yes, we have online, but I don't think that's advisable. Yeah, it's like a very important contract. So they said if you are anything like again, the first time you wrote the smart contract, you thought to yourself, why the smart contract starts with the license identifier? What does the SPDS license identifier mean and why do we reference to it? Wow. Okay, so MIT means Massachusetts Institute of Technology. So in my smart contract training thus far, I have found that many solid developers have answers to the above question. You simply copy paste into their code as a necessity without understanding what is needed for it. So let's just do it.
Wait, hold on. See the beauty of such. I mean, okay, okay. Like, what the beauty part about?
So that's what I just like. Maybe like you're writing Solidity and you don't know.
If you wondering why,
Yes, like you don't know why the license will be used or the license they have. You have them right. Yes, so why you are just using. So that's why we are doing it because so they said our daily life revolve around software. The power is digital age. We currently find ourselves for some software. Before we engage the benefits, we first have to agree on some terms and conditions regarding the activity. The condition precedent for the usage of the software is often contained in a file. The file sets the terms for the use of software. It contains some of the following. So this is why we are using the license, the essence to which the end user enjoys the software, in relation to the use of the software, certain the ability. This is what I'm calling. Okay, now can you see this unlicensed software, the license that we are using that like because even if you start a new project, I think the latest one now is just giving you unlicensed contract. So you say that unlicensed powered by, so you don't have the right to use anything. That was actually.
So, when you have a license, when you license, like when you have that, basically the license, like, what are the limitations of this license? Like, what does it stop anybody from doing? Like, do you understand? Okay.
So this is that. So in that they said why are software licenses important? They said software licenses are important for a variety of reasons to both the creator and end user. Some of these reasons are for creators to protect their intellectual property rights. Okay, so like our code that we are writing, we have to protect. Maybe we are building it for like for ourselves, like project, or like we are building for clients. So you have to protect it. Because like we also have what we call the entrance guide. The entrance guide. So it's just like maybe when the entrance does that, because when we are writing, there are some cases that you have to when you are dealing with money, like maybe you are building a contract that we draw, like you take a contract. So you have to modify it before sending money now. Like now I'm sending it a house. You know, like it's an external thing that can be when you're setting out that time that you're sending out. Some people might be trying to thinking on that maybe they are interacting with the content, maybe on that section. But when you are not you set it back to the normal when you send it like um
Okay, now, the way I get about the extra feature, we are trying to send, I want to send something to you, I want to send something to you. So let's say my balance is 20 now. So I want to send something to you, I want to send something to you. You know, and it's always be possible. But if there's a reaction here, I think it can be possible.
yes. So that way is that when I'm sending out, if I have more than that and I just want to send it out, if maybe like due to networking, I'm now clicking that button without not modifying the state. Okay, like before sending out, I have to modify my state to normal. Like before I send out, I have to make my contract to have deduct that money. Okay, yes, before modifying it. So when maybe because of networking, I'm not doing that. So user is now putting what the money is going to be.
So how does the license actually play a role in that?
So that's it. You're just that's what you say that we are property right. So for protecting the contract.
So basically, if something like that happens, they're trying to say that under this particular license, it's not my fault, it's your fault. Or
So now, because you're not protecting your contract.
I don't think from what we've just said now, I don't think I see play any technical role. You get apart from it, yeah, it sounds more like yeah. So okay, sounds more like a legal situation going on here. So if something like that happens, you're protected, you the developer, or maybe the application is protected under a particular type of your code can still work out. So
So now let's do research on that. We are going to do this.
like a copyright thing, but
Okay, so what's your question?
what I think I'm clear on the fact that it plays no technical role here. Right? Just want to go to that answer. Like what does that do to your code? Now you mentioned something about let's say somebody has $20 trying to send maybe $60 to one person and then you click it and it doesn't work and then click it again and again so you're trying to you can't I think it has something to say about maybe you can't sue or some situation like that, or you can't sue you. Something like basically just protect the thing. And so I think that would get us to dive in depth into like what each of these licenses actually are about. Basically. So you understand what rights you're giving to your users and what rights you don't have. I guess. Yeah. So GPS, when starting the Solidity file, you often see a line like this. So this line is called SPPS, like identifier.
So now, this is now. Saying that in Solidity, the SPDX license identifier, the line specify the license under which your smart contract code is released. So ensuring legal clarity and promoting collaboration by theory, defining the rights and obligation of users. This helps prevent future legal issues and foster trust within the development.
Okay, so I have to chat this with you to negotiate between all of those licenses. So there's one that says MIT. So when started, this line is called SPPX license identifier, and it helps specify the license under which the code is complete, and the obligation for you to modify and disable code. Now MIT license, this is the most permissive, allows anyone to use, copy, merge, publish, distribute, sublicense, or sell the code. Allows anybody to do that. Now it requires attribution credits to the original author person, and then it doesn't hold authors liable for damages, just like the thing you mentioned now. So that is the damage. Now it's good for open source projects that want wide adoption. And now GPL, GNU, and General Public License. Examples are GPL 3.0, GPL 6.0, whatever. Now it has strong copyleft. Any modified version must also be open source. Must also be open source under the GPL license. Now, good for projects that want to stay open and post forks to stay open too. So basically, it's any modification must also be open source. So if you take the code that you modify it, it must also be open source. So you can't just like take it and I think maybe you can actually be sued for it or something like that. So AGPL, Apparel General License, similar to GPL, but also requires that which one? GPL. No. The one that just mentioned. AGPL. Apparel General Public License. So similar to GPL, requires the network software like that must share source code. So they make sure that even if users interact with a smart contract over a network, the source stays safe. Good for projects that want even boosted versions to stay transparent. So basically, I think the idea is you just need to know what you're trying to do.
So I think that's why most developers use the MIT because I think the MIT
Apache for industries.
because like if you check the GPS for open source project.
Apache is having like a commercial project based on open sources. Like if you check Google give up as like the open source license guy to use, I feel like the most common.
Like, so I think this is something we should really research on our own channel, and it's not something we should well. Let us continue to take it out.
To be that at this default DPL and MIT is what we do.
Exactly. But I think
So
that
if you are now like going into maybe you get employed in the industry, and a lot of these things when you get maybe you get a job, you get to like there's a more all of this strategy, there's a more like more bigger like then the code another code dey inside that kind of thing. Still dey like another guy dey inside. So all this one we are still surface level. So let's is when like just to have like this background knowledge. The purpose is to understand how to write Solidity and so think that.
So yeah, let's proceed. So can we make reference to? I think the task we did that time. We actually have to restore the history won't make reference to that. Like, I won't make reference to that. Like,
That's one.
that's one.
Yes.
That's one. Only that's one.
That's
So we have to store. That's one, right? Only that's one. We have to store this thing as a zero five.
Okay,
When we make reference to that,
okay, we should do something like that.
no, like just make reference to it.
Like open the
Yeah. So we can compare what we have here.
Okay.
Sorry about my learning.
No.
Sorry, it's slow level.
Please, as you're learning, take notes so that if there's something you don't understand, you can always go over it. Like there's always something I can always mistake. There's always this assumption of knowledge when learning is because you ask questions. Now, me like knowledge, it's like the extra facts when you see that like starting we were able to learn more, right? So you assume that because you think that you basics. I'll just move. Senior day. Yesterday and today, don't write. Jesus.
Sorry.
He's born. In the first one.
My mentor.
Alright.
Okay, so this is my own
Okay,
contract.
so that
Okay, cool.
just complete. Create a new contract. Don't do that. That's the contract.
You also come out of that. Let's just okay. Let's just do this.
Go to workspace. Go to workspace. Yeah. Go to workspace. Contract. Um, new contract. Like
So let's just do one. Two,
with workspace back. No, no. It's like
okay. So basically, this is my own contract. It's just like the contract that you use it to add name.
I don't know if you noticed. Doesn't have a license.
Yes. So sorry.
No, I'm just saying like
Yes, I know.
actually it's just to show that
So
you can make
like
your
what we
own
just
online
did,
business.
so what we just like what we just learned now is one that like online is not good for not advise people. So because we just like a basic contract, so it's that we just use MIT or we just use that DPL anyhow. So this is the contract, this is Python contract that just for adding name, getting the name you added, and you can just add messages. So if you can I use array of messages, so I can add list of messages. So this is so I'm using array to for this for the string of messages. Right? So this is a new name, string of new name, for adding the new name. So string for temp name. So for adding this, so my argument is just a name. Because like this we know that this adding is just like adding field. And when I'm adding this argument just like input or let's just take everywhere. So when I'm writing this to the blockchain, so I'm writing this new name to that argument of this name. You know, where is this? Can you see all the names that I have? So internal name. The public is an argument. So like I'm writing this name, then this string, this string. I'm writing it to the function. I'm setting it. I'm setting a new name. Big, yeah, the function name, function name. So when I say this now, I'm not getting it again. I'm returning what I just said. So because I'm writing, I'm storing a data. I'm storing a data.
So if you are using you, you wouldn't have to.
Yes, I should. Should we try that?
Yeah.
In the
So I think certain data types require certain stuff.
Yes, man, that was
Not. Or if you are using you, you just don't have to. You didn't use memory.
think I want to
so those strings before the function, they are age.
what is it?
Those strings before the function, I think they are age. And
They are very good.
I think the first one is array of strings.
Yes, I'm very excited that I don't think because like I'm adding a list of messages. So
Where's the message? Let's
okay, you want to see the message. You can see like it's just like basically like JavaScript. How you push to an array. So just push. I'm not pushing to that variable that I just said here. So okay.
Work. So the only thing is to add that memory whenever we are supplying it.
Yes. So now this one is just like you know that this unit string is just like this part. So you try to be fair and check. So let's try getting now let's check this one also to you. You should be getting the so don't let me say so we're now returning the counter that
So without it doesn't count, I go without underscore.
so let's just try to run it and, so even this one if I just set it to 1.5 so when I just press compile to 1.5 no you coming here and just compile it. And counter so can you see so our counter now we have one counter
Okay.
so we get the counter that we just said. We don't update the this that we use. So we are not getting it. We can just change it to get counter. We are just doing get the name and just so we are getting so this one now for okay.
It's okay though, can compare one.
Yeah. What? Okay, get message. Yeah. I've not had it with new message. Yeah. Zero. Because I've not had the new message. No, our message is different from the account that I have. I've not had the new message.
So you added it to your Floyd code.
Yes, I can. Let me ask you. I will have message. Please send by that.
Someone to your Floyd code.
Maybe contact.
Your Floyd code, like Floyd
Okay, my error.
like when do you write that hello file?
Where so why how I do mine is just like I can hide when I deploy.
You can't,
I can hide when I deploy. That's how I do mine. I don't make it before.
you don't set
I don't take it like I don't make it. I make like when I deploy now I can add it and I can get so I can also add another one. I can also add another one. No, you try.
I think no, I think it's just people who solidity with
Okay.
but I think over here now it's like a lot of syntax. Let us go back to the way what we were. Get the compare. Yes, I do. Just wanted us to compare like what we did before and what we did now. See the similarity. This is solidity documentation.
So this so it's just like what? So this is when we are adding. Also go. I think we all understand, right? This is the word.
So if for example, it's only just the back end side, right?
Only the front one.
It does not contain anything about it.
Yes.
Because
It's just so for I think
it's supposed to be a introduction to something.
so I don't know.
But can we let us keep going like into the like let us look at Solidity by example. We need one. Should we was supposed to what name was supposed to have somebody? So you do you were saying something, yes, so you by example. Yes, you go by like 5 months. It's just like so it's a ground system like you know already said it. More work is on you. It's just like go for like example just together. Right. So when you now say class that was 2 times like over the team. Yeah, that was normally I wanted to like go by the different example. I'm going to come up and like do all the standard. And that's why you I was like, yeah, that's it. That teacher, and let us do it. So we have let us get for like when that is so they continue to try this one can go just help this one. Thanks. It's like
Um, so so this is just like a coin contract. So we have the variable of address public commuter. This means like this address public. You can see the address. We are mapping address to you in. So like they're just form the balance of the coin. So we have the keyword public variable. So it's just basically we have the visibility, we have public, we have internal, we have private, we have external. So what public does is just like maybe when you are working with complex, yes, complex contract that you have to specify. You can be using, you can be because we have what we call generic. Like yes, like maybe you are working with like maybe 3, 4 contracts. So one contract can be anything
without changing the form of that person.
you can multiply, you can still multiply.
No, like the first contract, like inheritance, like I'm not talking about the inheritance. It should be like you can change the like the rent coming after it. But it's not like okay, like
Okay,
this
I
one that you understand what I mean.
I experienced
You don't change the first contract.
like
Or the contract.
yeah. So now how inheritance works is that, like, I have this contract, I have this contract, and I have another contract. I can be using the function of this contract without one that
Instead of the other one.
inside once the visibility public. But if it's private, I can only use privately this contract within this contract. And also we have private too. Yes, I think I guess. So we have external too. This works like you can usually use outside. You can use yes, you can also use it outside this contract because you can use it outside of the when deployed. Let's see. What's it? I'm trying to check when you something because like even like that's like I think that's what you just need to know about.
I don't think you have to like
Break what I'm trying to do is that like before we know before we can even build any contract, like we have to know like all these things because we are working with different we can be using Ghana in some way. So we have to understand that.
Yeah, I understand, right? But what I'm saying is, solidity and documentation, one kind of understands that, okay, these are new concepts. So, just, I'm thinking those quick, and while you're speaking, you kind of like just go to the example, like, I think there are some things that should be our talk. So, like, currently, I'm looking at the like make those extras for a big line of code like that. Somebody can understand them. But under it, say this contract introduces some new concepts. Let us go through them one by one. So let's just try to focus on like the concept that you get.
So please just let's go to the other side. So this primitive data types for validate things. So here we introduce some primitive data types available to it. We have the boolean, we have the interface, we have the interface, we have an int. So so unit, I think we all know what unit. Unit, unit, on sign it. Yeah. I just want we are like okay now like so like now we have UX, we have two. So UX is content that can only take positive numbers. Int is just like it can take both negative and both positive, like your subtraction, your addition, like normal. Can take maybe minus int can say that, but UX don't count that. And we also have UX Python.
I think that's the best question. You actually talk about how to define variables for it when we started the class. Way back when we said we just talked about because we have control, we have not actually think that's the next one that variant.
Yes, that's what. So
Let us get through the data types.
okay now so okay so we have William, we have doing fighting. So like for only doing we have doing from doing 8 to 5 6. So it's just like
The 4 billion is false. What is it? The 4 billion is false.
yes for yes because yes
It was not the same. It's not false in the
yes.
So there's some important notes here that basically explain what
So now yes that's what I want to say.
we start from design this is a very big thing that
So
so can we talk about the minimum and maximum of fees?
that's what I'm trying to like doing from
There is 8, there's 2 prices.
And also, is there a minimum? Are there cases where it's important for you to use
Yes. When you're is more than 1
more than
prices.
no, that's what I'm saying. I'm asking if there's cases where it's important to use During where you can just
Yeah.
cases like
Like when you are like this addition of like numbers, something like that. If there are if let's say you are solving an multiplication now, and your answer will be like you are not sure maybe your answer will be minus or plus or negative or positive. You use but if I sure you don't want anything negative, if it goes negative, the contract like it's not like work, something like that. If you don't want it to work, you use this.
okay, so let's something like balance. You
Yeah.
cannot actually get your balance and
Yeah.
so now this is like an article for the unit was doing 5 6. So this article it says that it all started with a friend of mine asking why use unit 256 to store a small integer value rather than a unit shape. So this is a reentrance guide does go from OpenZeppelin. So OpenZeppelin is just like when you are instead of like maybe you are working with ER20, like you are working with complex contracts. So instead of creating your own ER20, OpenZeppelin just without. So for now, like maybe now, because the entrance guide, I explain what the entrance guide was. The entrance guide.
stop us from making
Yes, like
transaction.
yes, like yes, like protect our contract. So when you're working, so this in the instance on the entrance guide, we make the non-entrance require ability which can be applied to others to make sure there are no necessary entrance for them. So first them is like maybe like all these like just protecting us from all these attacks. So that was the entrance. So it says note that no entrance guides function marks as no entrance may not fall one another. So because now when you're working with complex contracts, so now it can be open to entrance. And be open to like maybe after your contract. So this is not really entrance. So when you're working with non entrance, you can't be calling that function. For example now. So this is now. This is a function called non-reactant default. When it first calls to non-reactant, data will be not entered. Requires tutor is not equal to enter. So you can't call this function because like you have already required the discipline that require that status is not equal to enter.
Okay, I get that, but I'm trying to link it back to where we're coming from. Data types. So how I think what the thing that brought us here was
During different between
yes, why store something during 8 so I think that
that's what you say. You can just use during say like I think the fight is just like no option. Like what I'm trying to do,
right?
yes. What I'm trying to like the difference because why we use doing say the like the side of doing the side of doing the doing that's what I'm trying
So it's because that we have set.
it's like they I think doing side is like the
This was like a picture from the
like seven
About the let me say about the 8 something like that. I think the maximum integer, like the size of integer numbers, you can't go down to 56 and something like that. Yes, it's like 2 raised to power 8. Well, if it is unit I think 16, 2 raised to power 16, that will be the maximum. So we use unit 56 because like we explore this one very large. Yeah, space.
Can we proceed? I don't think it's about ethics.
I'm not about space. The number of
If you say two raised to power eight now, the value of that raised to power eight
By
is the
the-
maximum. Let's say
Yes, maximum.
and supply to that value.
yes, that's
So if you're trying to store something like a phone number, you obviously need something beyond it. Yes, you need that integer that has more, you can take more digits than it. You're trying to store something like let's store balance and balance that go as far as billion. You have to use like
yes.
Go to Wikipedia and search go to Wikipedia. That's one of Wikipedia.
We are doing those. Let's say 2 times 100 and say
So I think I already had I have liberty to break it down. And this is the still take more. So basically to understand all of this, it's just like no. Not a certificate, just apps. Just like understanding the other types. Where you then but I think even with solidity by example. So primitive breaks it down. Okay, yeah, so this is it. So like if there are primitive data types and you have the sites on digital memory, like on what's what space be complete in your computer memory. So when you set an unsigned and a signed distance, it shows the range of the number, right? There's a reason why they use a signed number and unsigned number. Because that's what I'm trying to search. Signed and unsigned. I think we already explained that. Say you're trying to use something like balance. Like you're trying to there is a specific reason
why you like even in computer business, when you use
Yes, no.
sign and unsigned.
Wait,
Okay,
yeah.
no,
No. Yes,
yes. So they still have like so for example pointers and all of this. The reason why you use this thing. It's also like your yes, I remember your laptop architecture. If you notice, I don't know if you notice there's x86 64, probably something like this, or ARM 64 or AM64. So your laptop architecture, sometimes some laptop architecture do not accept only accept unsigned data types and then primitive types. Yes, and why some doesn't. So it depends. So some of them have like 32 bits, some of them are 64 bits. It depends on the architecture of like your desktop. So that's why we have different media data types. Some of these things you don't really need to worry. A lot of them just use your development pieces. Except you are doing like primitive, like for example, if you have to like build intensive computing for a single virtual machine, you're usually already using virtual machine and you're not using another architecture, you're not compiling to another architecture. You probably are using like native blocks and you need to compile to like the x86 64 the laptop or AM something. So that's when you need to like worry about that. So just use your default sign or sign this thing. So when you use the negative value, you use the sign rule. And when you use the positive value, you don't have too much time to be going to
I think the next thing on that, we go into it for example. Yeah. The next thing is variable.
So can you copy the next one? If you don't just search, you go to Wikipedia, search for all of these things.
Yeah.
So where are you?
Can you continue?
So that let's finish anything wrong with that thing. Let me just start. And when you don't like
Bro,
It's just like
Like looking at this thing now, what are the important things you need to take into consideration?
that's just really like how the people see.
yeah, so okay, you're trying to show them like different ways.
Like what we check now, like all these public yeah, so like that's what I'm doing. So let's just so we have three variables. So we have local variable, we have so for this variable, these variables are variable whose values are either permanently stored in contract storage or alternatively temporarily stored in intransient storage, which is claimed at the end of each transaction. So this is for an example now. We have a simple storage which store these six variables. We are storing what's it? Layout of the
So far, right?
so this stored this UIN stored data, this variable is a state variable like modified state.
No one say that the object objects and the object has behaviors and their states and their identity. So state variables are more parts of our program to modify the state behavior of our object or our contract. So in this is the contract. So
I'm looking for this.
Yes.
And
this is inside
Because now like
so this
the
document.
part of the contract that we
Yeah.
Okay. So now we have the state variable visibility. We have public state variables differ from internal ones. Only in that the compiler automatically generates data function from them, which allow other contracts to read their value when used within the same contract. The external asset, e.g. this dot x invokes the getter while internal asset, e.g. x gets the variable value directly from the storage. Data functions are not generated, so other contracts cannot directly modify their value. So I think I've already explained this public state variable. So it's just like your visibility, like when you make public, like you can use it inside the contract, you can use it outside the contract. So it's just about the contract that we set that we write before, like for add name and get the name. So add name just like setting, and while the getting just like they are getting what we just write to the state. So we have the internal state variables. So internal state variables can only be accessed from within the contract. So I've already explained this so that only inside the contract that it is declared. That's where you can use it. You can't be using it outside. Internal state variables can only be accessed from within the contract. They are defined in and in the right contract. They cannot be accessed externally. So now, like, for example, now,
So, like, when we read in what's the word? How we read? So when we read solidity, when we saw the introduction to solidity, it said that solidity has inheritances. Okay. So the right contracts are in object level. There's inheritances for the movies, like a contract that has different forms, right? So there are certain times we write a contract. So let's say we write a contract for a car, right? That is object now, class for a car. Now we want to write a class for a Camry car. We inherit the class of the car to define the Camry car. So for a contract space now, you can write a contract, a parent contract. Now the other contract can derive functionality from that same contract. So internal state variables, the right contract have access to it. But once you declare a variable private, you want that deriving it cannot have access to it. It's within that one contract that it is. I don't know if you get. Internal state variables. Yes, internal state variables can be derived by another inherited contract can have access to it. A private contract is within the boundary of that contract. No one else can have access to it. It is here. But like an internal, we're saying that even though it's private, an external, the only person that can have access to that variable is the contract system and the contract that is derived from it.
I just want to use as an example. So I use this function as private. If we deploy it now, we won't see this function because like it's already going outside the contract.
So this add message now is within that contract. Contract, what's the name of the contract? The 5-point contract. Anyhow, that 5-point, that counter contract, the contract is in the it's only the functions within. So if you now it can have access to that add message function. But when we create a new contract, it doesn't have access to that add message. if we create a, if this contract is derived from another contract, let's say we create another contract and let's create a contract that defines what the message looks like. Now, this add message, we now see this add message to inherit the properties of that message. That message can have access to it if it is internal, because it is still within the mother contract. I don't know if you get. See it as a tree. There is a mother contract. If this contract derives value from it, I don't know if you get now. It can have access to it. When we write it, when we get there,
right. So now you can do that. This add message. I made the visibility private.
Right.
So when I deploy it now, I can't see the function again. It's not visible again because like it's already outside the contract now. No, I mean they are I've set it as private. Only I can have access to it. So now, like maybe I want to call, I write the function that I want to call this function that I want to private. I can still be using it inside the contract, inside this file. But because I deploy it not on the blockchain, because I've deployed it to the blockchain now, and the visibility is private, I can't access it. So that's private. But yeah, so, let's go back. That's just for like an example. So we also have internal, I think, internal can only be accessed from within the contract. They are defined in and derived contract. So internal now, so like maybe I have two contracts. So about the that's the contract. And I think internal. So just I have a function in the derived contract. So I need that function that I just take as a standard. But private because when you're saying contract, I keep saying files, but I want to like kind of separate everything.
the other thing to say that why there's like similarities, try to like Solidity is like the language of a lot of why it inherits like so people that wrote it seem like still with the language of the tool. It has its own sets, in React. They're using React set state to think about text React is entirely different. Is to update and remove on the doctrine. So now here you are not removing an update on the DOM. I'm not talking about it like that. It's talking about a component theory. Right? Now you know the component, the writing the function. Like even if you are going to do a state system, React is out of thinking like you have to like state system normal thing there. C# Java, something like that. So, but like, although React state management system borrows there is a state system for your language, for compiled language, for your programming language, for your machine. Like for the state management system on React or Vue is built on the doctrine for the web. I don't know if you get there. For you have to specify.
Even like if you see like if you remove the visibility now, then you trigger an error that I need to give it check now. I need to know visibility specified. If you intend to add public, okay. But if you're maybe like you are using that, it's not going unless you are using maybe copilot, it's not going to give you that. It's just going to turn error. So you are not even like this. You won't be able to compile. You can't be able to compile because it's showing an error now. You can't be
like the thing about when you say contract, you read the .sol file. That is the contract. Or you have like you can have multiple contracts in one .sol file. It depends. That's the thing I'm trying to get.
It depends. But because of you want to for the interoperability, you want to state a contract by file. Like this one is why it's
Okay, so each contract, yeah. So that's okay. Now it's going to come together.
yeah. So it's like saying that I will not say contract and components. Like
That's why I mentioned that.
so now React is any stage. React is a class-based component. Now you use a function-based component. You can still write class-based function. I would start with and I'll show that because of your React, you are still using React. I'll show you there's class-based. Yes, I'll show you if you can start with class-based components in React. You see all of these things. So you see how we update the states manually. Because you have to now you can just set states and do that. Before you have to set, you have to set all of it. On mount when it's mount, which the state starts to go in the mount and everything. That's like 3 different. You have to manually update on it for the class-based components.
So maybe this contract, this contract, they have 4 contracts.
You have 4 contracts.
So now, this is the main contract. This is the main contract. You see, I have in traffic, but let us go into that traffic. So then it's about to
Does this interface work like the interface in TypeScript?
No, it doesn't exactly work like it, but it's almost the same feature.
So can you say that I'm importing that main contract here?
So this one is inheriting.
I'm inheriting that main contract from here. So I can have that I can have
Something that attribute is internal.
I'm trying to check maybe there is like a content that I'm using, but I don't think I have it here. So it's just like so like it's just like it's one contract. That means main contract. What is function that function that other contract because that means contract. On that base can work, I can see all the function that all of them in that one contract. Sorry.
Let's keep going to
So like let's get in the language so that we can
give more
So we have already explained this private secrets are like internal ones, but they are not visible in derived contract.
so